Hello, everyone. Our project focuses on predicting whether a loan application should be approved or not, based on the default risk prediction. My name is Zheng Yisui, and here's my teammates, Cooper Yang and Zihao Fu. Next slide, please. And here's a brief outline about our presentation today. As for the background, when an applicant applies for a credit card or a loan, the bank should decide on whether to approve the application or not. This is crucial to banks because they are businesses that live on such loans and the revenue from the interests. So accurately identifying potential risk and rejecting the application and recognizing stable profit chances and approving the application are both important to the overall revenue and profits to the bank. To achieve that, apart from the manual inspection upon the application's background, a robust and scalable model to accurately assess each application's credit score is also necessary. So hereby, we propose several data processing and modeling methods to achieve the goal. And as you can see, the data we use, the source is FFIEC, which is Federal Financial Institutions and Examination Council. And we use the Home Mortgage Disclosure Act data of New York State in 2020. The dataset contains 99 features with numerical, Boolean, and categorical data type, involving the loan details and the application's financial information. And it contains over 700,000 samples, which is for purposes. And next slide. So with our data on hand, we first clean the big messy data in regards of missing values and outliers. And besides, we implement one-hot encoding to make categorical data available for modeling. And the next slide. So to check the missing values, we computed the percent of missing values of each column. And for those features with over 50% missing value, we simply removed it because the information they can give is rare and imbalanced. And for those with less missing values, we impute them with the median or mean of the feature according to the distribution of the feature. And next slide, for the outliers, we check by box plot as well as the summary statistics such as the mean and max, mean and median, lower and upper quartile, as well as 95 and 99 percentiles. As for the outliers in numerical data, based on the magnitude and the skewness of the distribution, we replace those outliers with 95% quantiles or the logarithm transformation, which proved to both work well. And as for the categorical data, we simply replace the outliers with the majority vote. And that's it.
Okay, after we finished our data cleansing step, we found that our response variable, which is the action taken, have huge differences between two classes, just as the below bar plot shows. There are about 400,000 records for accepted applications, but only 100,000 records for denied application. And such heavily imbalanced will affect our accuracy of our model. So we decided to use oversampling to resolve such issue. And by doing that, we made multiple replications of the minority class, just as the plot shows below. And after all the data processing step, we start our data modeling. We basically use 4 data models. The first one is logistic regression. The second one is PCA and the logistic regression, and then the boosting tree, and the last is the random forest. And the first, we perform a basic logistic regression model. And as we can see, the performance, the accuracy, and the recall are pretty low, which is not ideal for us. So this model should still be improved in the following steps. So in order to improve the performance of our logistic regression model, we apply a principal component analysis on our dataset, which helps us decrease the dimension of our dataset from over 400 to about 200. And after doing that, as we can see, the performance of our model have hugely improved, and the accuracy is about 0.8, and the recall score is about 0.7. However, the recall score is still pretty low for our targeted question. So we decided to use another model to get a better performance. And the model we choose here is the boosting tree. And we just use the gradient boosting classifier from the Python. And as a result, we can see that we have a brilliant performance of our model. The accuracy here is about 0.969, and the recall score is about 0.998, which is pretty good for our target question. And also, there are 10 top features selected by this model, and the top 5 features are whether this applicant have high cost mortgage and the interest rate of this application, and also the type of entity, whether is it applicable for the mortgage application, and also the total loan cost, and also whether the mortgage law is applicable. And next, our teammate Cheng and Yang will talk about the random forest we did.
So thanks to Hao for sharing the PCA model and the gradient boost model, and how these models pick the important features like transform the data and make the predictions. So as we compare to the gradient boost classifiers, our group also runs random forest model to pick important features, and we are trying to improve the model performance. So in general, the model performs very well as compared to the baseline model with logistical regression. The accuracy score and the recall value have been boosted to above 90%, which is like a 30% improve, which is amazing, and we think it's a good condition. And the performance result determines that the random forest method is a good way for this model to select features and predict our results. So with this model, the most important features including the mortgage value, interest rate, and total loan cost, which is very similar to the gradient boost tree. And in common sense, this feature should have some positive effect to the results. And go to the next slide. So in a summary, this table displays the overall performance for like the baseline model, the PCA and the logistic regression model, the gradient boosting, decision tree, and the random forest model. So from the table, we can see with comparison, we can tell that all three models greatly improve the performance. And among the random forest and the gradient boosting decision tree outperforms the PCA method. Their accuracy has reached near 95%, and the recall score is near 100%. And their important features are very similar. And we go to next slide. So as a result, we pick gradient boosting decision tree as our ultimate model to decide whether applicants are eligible or not for their mortgage application. So as the gradient, we picked the gradient boosting decision tree because it has the highest recall score. And we know that the recall score indicates whether the model could correctly deny applicants that do not have qualifications. So for this model, the top features are applicants, whether they have a not high cost mortgage, and whether the interest rate is low or high, and whether the type of the entity is applicable, and whether the low cost is low or high, and whether the mortgage value is low or high. And so go to the next slide. So even though we got a good result for the performance for our model, there are still some imperfection and some concerns for our model. First is about the fairness problem. For our model, we try to elevate the fairness problem by not selecting gender, ethnicity, or some similar variables as our features to determine eligible applicants. However, there is still some problems. For example, it's very hard for us to define similarity for our targets, considering the individual fairness. And that is one of the limitations of data science. There are too many human factor issues. And we can go to the next slide. So next slide tells us what the problem we met. So we met with the problem of data bias in the exploration of data sets, and this is a problem we want to fix in the future. The problem is that the label of our current data set is whether approved or not, but the real label for bad loan should be the historical default data. So here is a sample bias. The data bias will train a more optimistic model and causing problems. Dealing with such bias issues are worth discussion and may be solved by rejecting inference methods, and that will be our next step. So the next slide. Our conclusion for this project is that we will use gradient boost tree to train our model and for the prediction, and it is a reliable model for our client to keep the balance of profit and the risk. In the real scenario, an applicant with not high cost mortgage, low loan interest rate with type of entity applicable, low loan cost, low mortgage value will have higher chance to be approved for the application. And our next step is to fix data bias while elevating fairness and data science limitation. And this is all for today's presentation. And if you have any feedbacks, feel free to comment in our GitHub page. Thank you.